All right, so let's look at prefixes, and the basic lesson would be to understand why we use prefixes, what's the significance and what's the importance, and what would be the basic benefit of using prefixes. Now, prefixes would be letters that are added before a unit. Now, for example, if I write down that a unit of, for example, the length of an object, let's say, is 35 centimeters. Now, this letter will be considered, or these numbers will be considered as magnitude of that number. And this letter, the second one that you usually see, is actually the prefix that you can find in this table as well. Over here, you can see this value over here. And the last letter that is represented is actually the SI unit, which we so conveniently ignore sometimes that we forget that what this number actually means and what these values actually are. So, and similarly, for example, I could have selected any prefix from this letter, from this table, and could have written down any sort of number. So for example, this is unit of length. I could have done this for time as well. For example, if I say that this is 25 ns, that n is actually going to belong to nano, which is this one. So this is basically 25 nanoseconds. If you open this up, or if you want to convert this, what you generally do is that you write down 25, the number as it is. Then you'll have to memorize this whole table, and from memory you're going to engage that nano has a power of 10 raised to the power minus 10. So just in place of this nano, you're going to replace into 10 raised to the power minus 9, the straight value taken from the table that you've memorized. And be advised that the unit, since this was time, is not being affected. Seconds will still be a part of this measurement as it is. So that is how you open up this value. That is how you understand it. And generally, to understand what is happening at the back end, what's the mathematics behind it. Now, for example, in mathematics and in physics and chemistry, you're generally told that you have to convert every unit or every number back to SI units, or actually in terms of their standard units. Now, we know that length is represented in meters, time is represented in seconds, and so on and so forth, the table of base quantities that you've memorized in physics. Now, let's say that if this 35 centimeters was given to you and you were supposed to convert this into meters, let's say, for the sake of example, that you were supposed to calculate speed, but it was supposed to be in meters per second. And the measurement is given to you in centimeters. So most definitely you want to, or you have to convert the centimeters into meters. So what you generally do, basic technique is to divide 35 with 100 to get it into meters. And if you had millimeters, for example, let's say 47 millimeters, then what you do is divide this 47 with 1000 to convert it into meters. Let's try to understand the basic mathematics, that this table is more convenient than to memorize or than to understand how many divisions or with what number should you divide it. So let's say, let's carry on this number. So this is 35 divided by 10 square. If I write down 100 as 10 square, I'm sure that there's no problem in that. And if I bring this numerator into, denominator into numerator, this becomes 35 into 10 raised to the power minus 2. Now, what you were trying to do is convert this centimeter into meter. And if you go back to the table, notice that when you divide it with 100, you're basically adding a multiplicity of 10 raised to the power minus 2. So instead of dividing this with 100, 1000, and so on and so forth, and if you had to convert this into micro, then it would be even more difficult, because then you'll have to add 6 zeros. Then for nano, you'll have to add 9 zeros. For example, if you had, let's say, 58 nanometers, then this 58 would have to be divided by a number that has 9 zeros. So instead of this, this is your option A, and this is your option B. You memorize what is nano, that is 10 raised to the power minus 9. You simply write down 58 into 10 raised to the power minus 9, and the unit of the quantity comes back as it is. So it's very obvious that option B is a more safer choice. It's a more convenient choice, because you were doing this in the calculator. It's possible that you may add one extra zero or one less, or it will take more time to make this calculation, or to at least read it, right? So that is why we've developed these prefixes, that instead of adding more number of zeros, instead of adding or counting the number of zeros, it will be easier for us to just replace those prefixes with their respective powers or multiplicity, right? Now, the basic idea again behind this 47 would again be that if I write down 47 divided by 10 raised to power 3, there is no harm in that because 1000 can be represented as 10 raised to power 3. Now, if you take this denominator into numerator, 47 is not being disturbed, it's still there, but this 10 raised to power will be considered as 10 raised to power minus 3, right? So now if I go back to the table and I see what this 10 raised to power minus 3 actually represents, I can clearly see that 10 raised to power minus 3 is a prefix for milli, and I can then conveniently replace this as 47 milli. And of course, the unit is still missing. We don't know what the unit is. Is it time? Is it length? Is it current? Is it temperature? What that is, we don't know. So it's just a number right now, right? Okay. Now let's try to do one more thing. Now, for example, if I write down a number that is 0.000, let's say this is a mass of a small particle, right? This is a mass of that quantity or that object, whatever that is. Now, let's try to, if we were trying to find out density, and the formula for density is mass over volume, it would be highly inconvenient for me right now to add this many number of zeros into the calculator to perform this calculation. So instead, what I'm going to do is I'm going to convert this into a standard form, or to use at least a prefix to make it more easy for me to understand. So making 3 jumps over there, so 3 jumps, then 6, then 7, then 8, and then 9. If I make 9 jumps, what happens is that the number that I get is going to be 34.8. Why? Because if I select 7, the next number is 8 greater than 5, so I'll be rounding it off. This will become 8. If you're not comfortable with this, what we can do is write down the number directly still. So 8, 3. But since I've made 9 jumps, I will add a power of minus 9 to this because it's a very small number, right? Okay. So I go back to the table, and again, I keep referring to the table, which should be a part of your memory. You should memorize it, that it is 10 raised to the power minus 9, which is nano. So I can very well write this number as 34.783 small n nano, right? So what we understand right now is that instead of writing down this many number of zeros, and even for the examiner, it's not convenient for the examiner to write down this number of zeros, right? So they will give you all the values in the examination, sometimes to trick you, sometimes they will be in plain sight, so that you can write down large number of zeros in less number of letters to add convenience and to remove source of error. It's possible that you write this down on the calculator and you might add one more or one less zero, which will disturb your final answer. Now, the Cambridge criteria for physics paper is 2 significant figures, and you have to make sure of that. What is 2 significant figures? Significance would mean importance. Is this number important or not important? That's the basic question that you have to ask. So right now, if I had to round this number off to 2 significant figures, what I would have done is 35 nano. This is its 2 significant figure. Let's discuss what is 2 significant figure. In the next part, we will learn how to put these number on the calculator and how to take the help from the calculator in writing down these numbers. So let's see what is significant figures. Okay, so 0 is sometimes a significant number and sometimes it is non-significant or insignificant. But all the other letters in number, that is from 1 up to 9, there will always be significant. It does not matter where they are, they will always be significant. And forget about the decimal point for now. Decimal point has nothing to do with counting significant figures. Decimal places is a separate issue and significant figures is a separate issue, right? Okay, so let's see what we mean by this issue, that the letter 0 has sometimes is going to be significant, sometimes going to be non-significant or insignificant. Let's see. So if I write down, let's say, a letter that is 4, and if I keep on adding zeros to the left, it does not change its value. It is still going to be considered 4. And you can check this on the calculator by writing down this number and pressing equals to, you will still get 4. But if you add these zeros after the digit 4, then most definitely they increase its value. So we can deduce from this point that 0 will become significant when it's after a significant number. If it is placed before a significant number, it will not be counted as a significant number. It will not be counted as a value that adds to the magnitude of that value. If we can see that 0 was added on the left, it still has not increased its magnitude. But if 0 was added after a significant number, it definitely increases its value, right? So let's try to understand the significant figure in some form of examples. Let's say, and for now, I'm going to ignore the decimal places. Okay, so 0.003756438. Let's say this is the number that we've written down. And if he asks you to convert this number into X number of significant figures, for example, 1 significant, 2 significant, 3 significant, 4, and so on, students generally get confused by this decimal point. Decimal places are a separate issue and significant numbers are a separate issue. Just forget about the decimal place. This will not be asked in physics, right? You will always be asked about significant figures. And you have to write down your number up to 2 significant figures unless the examiner asks you to mention that in 3 significant or 4 significant. Now let's try to count the number of significant figures. Now again, if I start counting, I have to start from this point, and I see that I first encounter a digit 0. Right now, the digit 0 is insignificant because it is still before a significant number. It's here all alone, so it will not be counted. This will not be counted. This will not be counted. Now let's add a bit of a problem here so that we can understand it fully. Now, the moment I recognize the first significant number, that is, could be any number from 1 to 9, I realize that I should start counting, right? So this will be my first significant number. This will be my second significant. Now, why am I counting the 0 right now? It's because of this idea. If the 0 comes after a significant number, it will be counted as significant. If it comes before a significant number, it will not be counted as significant. So keeping that in mind, this will be my significant to second significant. So if I had to write this number down to 2 significant numbers, I would have written down 0.0031. Why 31? Why not 30? Because when I reach my final significant figure, I must consider for the rounding off issue. So I have to round off in all circumstances, and I consider that to make this number as 0.0031. Now notice that if I was looking for 2 decimal places, be advised, if I was looking for 2 decimal places, then irrespective of what is the value after the 2 decimal places, I would just mention that. So if I write down this to 2 decimal places, I will write this down as 0.00, which is approximately 0. But when I say 2 significant numbers, I still have to go up to the point when I first encounter the first significant figure. I must see a significant number, which is from 1 to 9. And if the 0 is placed after the significant number, it will be counted as a significant number. Now let's try to do this again with the 3 significant figures in mind. So if I had 3 significant figures in mind, I would have started counting. This is not my significant. This is not. This is not. This is also, and this is also a significant number. So I will write this down first as 0.00, my first significant, my second significant, and my third significant. But when I take a stop at third significant, I consider the next place for the rounding off error, and I see that this is a greater number than 5 and more than 5. So yes, this will cause a rounding off. So this would become 306. If I had to write this down up to 4 significant figures, so 0.00305 and 6. Now notice that when I get to 6 for the 4th significant figure, I realize that the next number is 4, which is not going to cause a rounding off. So I leave 6 as it is, right? And please be advised that don't try to make this look like more mathematical in nature, or just because of your own ego or past experiences, that there are going to be more number of zeros, or this less number of zeros does not look good on mathematics, on account of mathematics, or something like that. Don't think like that. Just don't forget the rule. So if you add, for example, for the sake of understanding, if you add another 0 after this, this will no longer be a 2 significant number. This will now become a 3 significant. Why? Because we know that 0 after a significant figure becomes important. This is now a 3rd significant figure. So you can't do that just because it doesn't look good on account of mathematics or on paper. And similarly over here, you cannot add a 0. This will now become a 4 significant figure number, which will be wrong. right? And same thing can be done. Now, this is with a decimal place. You can do the same thing with a number that is larger than that. Let's say you have a number that is 473,584, and let's say we have 983, right? Now, if I tell you to write this number down to two significant figures, then you're going to most definitely start counting from this point. So this is your first, this is your second. The next number does not cause a rounding off. So two significant number would be 4, 7, and the rest of the places will be filled with 0. And for this one, we have the standard notation that we represent this as 470 into 10 raised to power 6. These 6 zeros will be written down as this one. And to put it in a more simpler perspective, this can be written down as 4.7 into 10 raised to power 8. As you jump more two decimal places, it will add 2 more powers into it. This is what it's going to become, right? If you had to write this down into 3 significant figures, then this would become 474. Why? Because first, second, and third, but the next number causes a rounding off. So I'll have to consider this as 474, but the rest of the places will be filled as zeros. So right now, this number is written down to 3 significant figures, or rounded off to 3 significant figures. Again, we are not concerned with the decimal place, be that a small number or be that a large number. It doesn't matter, right? So this will be our full understanding of significant figures and prefixes. Again, prefixes are there to make our life easy. Similarly, over here, what you could have done is, let's say that if this was power 6, for example, I'm considering this example again. If you had 470 to 10 raised to power 6, what you could have simply written down as 470 mega, capital M, because if you go back to the table, you see that this 10 power 6 is mega for capital M. So the examiner can either give you this format, or it can give you this format, or it can give you these large decimal places or long values. But you should be able to convert this into a standard form. This power notation is known as the standard form, right? And this is where we add a prefix. Again, this is all being done for the sake of practice, so that you understand the larger concept, that why are we doing that? What is the benefit? Now, since we have understood what are prefixes and what are standard forms and notations and significant figures, let's try to see how to put these numbers on the calculator. Now, what I would like to bring to your attention is that you may be familiar with these two types of calculators. If you have a different one, don't worry, you will still have those numbers with you. So the first digit that you must be familiar with is this last button that represents x10x. And on these calculators, this is going to look something like this, a bit different. So this is that number over here in these calculators. Again, x10x. I'm sorry, it's with the yellow color. Let me change that. So this is x10x, right? And the second digit that you should be familiar with, or the button that you're familiar with, it should be over here somewhere. That is ENG, engineering mode, right? And over here you will see this ENG as well. The third button that you should be familiar with, and that would be this one, the fraction button, that looks like this. And on this calculator, it looks like this, right? So my request right now would be to forget about this division sign for larger calculation. If you're just dividing 5 divided by 3, then that is fine. But if you have multiple numbers in your calculation, then please avoid using this fraction symbol, avoid using this division symbol, and use fraction and brackets. These are your brackets. So please start using brackets and these buttons. Now let's see buttons. Now let's see how are we going to use these buttons for our advantage. So let's say if you had to put in, let's say 4.89 into 10 raised to power minus 5. How would you put this number into the calculator? So what you're going to do for both of them, I'm just going to choose this one for the discussion, but you can do this for both of them. Simply first write down 4.89 by pressing this 4, decimal, 8 and 9. So on screen, you will see 4.89, right? Then just once only, don't add this multiplication sign. You don't have to do that for this one. Just press this button of X and X only once. You will see that on your calculator, you will see a very small 10 written over there. Again, you don't have to go into the power mode for this calculator, for this button. That is why this button exists. It's going to make your life easier. So since you have to add a power of minus 5, then simply press minus and then press 5. You will see on the calculator something written down like this, right? So then you can add brackets if you had another letter, if you had another number, let's say, with some other quantities, you could have done that, right? And if you want to check this, you just write down this number on the calculator, press equals to button, and you will see that the calculator will show you exactly this value on it, which means that this button actually helps us to remove the problem. What students generally do is that they write down 4.89 and then add the multiplication sign, then write 10, then go into the power using this X button, this one, go into the power, and then write down -5. The thing is, they are exactly the same, but for this one, I believe that you'll have to use more number of buttons. It has a bit higher chance of error because sometimes you are not over there, you're not in the power, and you write down -5. You have to come back to edit the equation again. That calls for some extra usage of time and some form of error as well. So get yourself familiar with this X10X button. Now, once you've done that, and this works equally well for positive powers as well. So for example, if you had a number of 755, let's say, into 10 raised to the power 8, right? So what you could have written down is 755 on the calculator, then press that X10X button just once, and then press 8. You will see this on the screen of your calculator, right? Which is exactly the same. Now, why do you use that again and again? Where would you use that? So sometimes in the chapter of electromagnetic radiation, you see that the speed of light is 3 into 10 raised to the power 8. Students generally convert this into a number with 8 zeros, and again, that defeats the purpose. Then what's the benefit of using the standard notation if you're going to write down zeros? So instead, what we can do is use this X10X button on both calculators and be done with it. On a few calculators, I would like to bring your attention that on FX82, 100, and probably on 358, if my memory serves me right, that the X10X button is actually replaced with a button that is known as EXP. So don't worry about that. It's exactly like the X10X button. It will serve you the exactly same purpose. The only difference is that what you're going to see on the screen is that, for example, if you write down 3 into 10 raised to the power 8 on your calculator that is of this model number that has EXP, not X10X, you will see 3 small e8. So don't worry, this is exactly the same representation as this one. Go ahead and practice with this. And the last button that I would like you guys to be familiar with is the ENG button that is over here on both calculators. So the ENG button actually helps you shift powers. Shift powers. Now what powers? When I go back to the prefix table, your ENG button will help you shift your values between these tables or the values of this table. It makes a jump of 3, 3, and 3, and even for larger powers, 3, 3, and 3. So let's say that you have written down a number as 38 into 10 raised to the power -9. You press equals to, and your calculator shows you exactly the same number. And right now, if you press ENG, it will, depending upon the model, that's why I'm not giving you a confirm answer. Depending on the model, it will actually take you to either one larger power. Let's say it could mention that this is 3800 into 10 raised to the power -6, or depending upon the model, it can either take you back like 0.038 into 10 raised to the power -12, right? 1, 2, yeah, something like that, right? So it can either give you -12 or -6 depending upon the model of the calculator. I might be making a mistake in the number of zeros, but you can see that happening in front of you if you press the ENG button after you've written down this number or after you've obtained a result of some calculation. Now, if you do that and you want to go back, for example, to the original calculation or the original value, what you can do is you can use then press Shift and then press ENG. Don't push them together. First push Shift and then push ENG button. Where can you find the Shift button? You will find the Shift button over here at this location for both calculators or for most calculators, right? So Shift and then press ENG. It will again try to shift the powers back to either -9 or take you to this power. So then it's all up to you now. You go ahead and practice. You go ahead and see what your calculator does, what your calculator actually, how it performs. So you can be familiar with that so that when you go for the examination, you can actually use it to your advantage. And there is no compulsion. There is no issue from the examination or the examination centers that you can't do this or you can't use this. Of course, in mathematics P1, you can't take the calculators with you, but in all the papers in which you have the liberty to use a calculator, you can most easily, very well, use these buttons on the calculator for your advantage. And please be advised, memorize these prefixes table, and this will always be a part of one or the other question that actually confuses you. One of the examples that I generally give to my students is regarding frequency, and if you are new to this side of my videos, you will not see this until you go to the chapters, or unless you are actually going to cover the chapter of sound waves, which is a second year of O levels or IGCSE. So sometimes what he does is that he gives you that the frequency, or you have to calculate the frequency if the time period is given, let's say, and the time period is given very confusingly as, let's say, 25 milliseconds. Now, students generally ignore this M and consider this as a misprint, and they think that this might not be a unit of time. So the formula for frequency is 1 over T, and this is T. If you don't know this right now, don't panic. We are looking at something else. We are not concerned with the formula, we're concerned with the values, how to put them. What students generally do is they write down 1 over 25 because 25 is the letter that they can see. But what they're missing out is this letter M, which is a prefix. They've missed out on this, and you will get the wrong answer. So this will be wrong. So please, this is your SI unit, as I've explained in the very beginning of my video, how to look at a number, what's magnitude, what is its prefix, what is its SI unit. So over here, I can see that this is milliseconds, S is for second, that is for time, and M is for milli. Since it's a small letter, it's for milli. It's for a prefix of -3 because I memorized it, right? So I write down 25 as it is. I'm not going to disturb that number. And in place of milli, I'm going to write down 10 raised to the power -3, and the seconds value comes as it is. That's the unit. Now, if I put this into number, how do I do that? Again, use the functions of the calculator. Press the fraction button. You will see an empty fraction on your calculator. Then push 1 for this. Use the arrow keys on the calculator. Where are the arrow keys? These are the arrow keys on the calculator. Use these arrow keys to come down to the fraction. Come over here. You will see the cursor blinking downwards, right? And then simply write down 25 and then use the X 10X button. You will see a small 10 and then simply write down -3, not in the power, but directly. That's why we're using this number. Okay. So directly write down -3. Then press equals to, and then you will get your correct answer. Right? This is the actual, you can say, summary of why we are doing prefixes and why we are learning that and how to put them into the calculator, how to use that. Right? That is all for today.